Have you ever listened to a song and just wondered what makes it click? You know, what makes it all work so perfectly? Well, it's way more than just raw emotion. Today, we're going to pull back the curtain and uncover the hidden logic of music. It's like a universal language, and you'll see it has these incredible connections to math, language, and even computer code. Let's dive in.
So, let's start with this big kind of philosophical question. Is music art or is it science? Is it all just about feeling and creativity? Or is there some kind of system, a structure, a logic hiding just beneath the surface?
Well, the truth is, it's absolutely both. I mean, of course, music is one of the most powerful ways we express ourselves creatively. But all of that beautiful expression is built on a foundation that's incredibly structured, totally measurable, and really logical. And today, we're exploring that logical side.
First things first, let's talk about the absolute fundamentals, the musical alphabet. And right away, you're going to see how it ties into something we all use every single day, language itself.
So in Western music, pretty much everything is built on just 7 letters. That's it. A, B, C, D, E, F, G. When you hit G, the whole cycle just starts over, but at a higher pitch. We call that an octave. These 7 little letters, they're the basic building blocks, the alphabet of all music. And check this out. This is such a great way to think about it. On the left, you see the letter A. It doesn't matter if it's in a fancy serif font or a simple sans serif, right? It's still an A. Well, music works the exact same way. The note A is always A at its core. Whether it's a really low rumbling A3 or a super high A4, the font might change, but the symbol's meaning, that stays the same.
Okay, so if notes are like letters, what happens when we want to, tweak them a little bit? What if changing a note wasn't like changing the font, but more like doing a little math problem?
This is where these little guys called accidentals come into play. These 3 symbols give us amazing precision. A sharp, that's the hashtag-looking symbol, raises a note's pitch by 1 semitone, which is the smallest step we have in Western music. A flat does the opposite. It lowers it by that same amount. And the natural sign? Think of it like a reset button. It just cancels out any sharp or flat that came before it.
And this is where it gets really cool. This slide lays out the connection to math so perfectly. Look at that top row. An F sharp in music literally means take F and add 1 semitone. In math, that's just x plus 1. Same logic. Now look at E flat. It means take E and subtract 1 semitone. That's x minus 1. See? These accidentals aren't just random symbols. They're basically mathematical operators that change the value of the notes.
All right, let's build on this. We've got our letters and we've got our math operators. But what happens when 2 totally different things can actually mean the exact same thing? Well, this is where we get a little connection to computer science.
The concept is called Enharmonic equivalence. Whoa, that's a mouthful, I know. But the idea is actually super simple. It just means that some notes sound exactly the same but have different names. I love this term for it, sonic synonyms. They're different words, or in this case notes, for the exact same sound.
And here are some of the most common examples you'll see. The pitch we call F sharp. It's the exact same sound as G flat. C sharp is the same as D flat. E flat is the same as D sharp. They're just different spellings to get you to the same sonic destination. So you might be asking, why on earth do we need 2 different names for the same sound? Well, this computer science comparison explains it perfectly. Think about it. A programmer can write the number 15 as 11111 in binary, or just F in hexadecimal. They both mean 15, right? The programmer just chooses the one that makes the most sense in that specific context. And it's the exact same thing in music. A composer will choose F sharp or G flat depending on the key of the song or what chords are around it. The spelling is all about the underlying logic. Okay, so we've jumped from music to language to math and even to computer science. Let's take a quick step back and look at the big picture here, because this is really why it all matters. So what's the big takeaway from all this? It's that music isn't just some random magical thing. It's a deeply logical system. First, it's a symbol system, just like any language. Second, it has clear rules to transform those symbols, just like math. And third, what those symbols mean depends entirely on the context, just like in programming. It's these universal ideas that connect everything.
Now, seeing these patterns is one thing, but actually playing around with them is where the real fun begins. So now, it's your turn to make some of these connections for yourself.
So what do you say? Ready to try thinking across these different fields?
Here are a few fun challenges to get you started. Try taking a simple tune, like Twinkle Twinkle Little Star,
and mapping it out as a sequence of math operations. Or find a piece of music and try to figure out why the composer chose to write G-flat instead of F-sharp. You could even try composing a little melody based on an idea like, say, exponential growth. This is how you can really start to see that hidden logic in action.
You know, when we start to see music as this logical, interconnected system, it just unlocks a whole new level of appreciation. And it leaves us with this really fascinating final question. If music and math and language all share these deep underlying patterns, what other amazing hidden connections are just waiting out there for us to discover? Thanks for joining this explainer.